Hey, welcome back, gang, and to this, our first lecture on PL/SQL procedures. Yes, we're finally going to write some code. In particular, we're going to write a pretty everyday applicable procedure in this lecture, which will accept an external XML file, parse that guy into the corresponding relational tables in the database. Should be great fun. Let's jump in there and take a look.
Alright guys, I'm now looking at the lecture 9 script.txt file, and I see a number of commands at the top of the script which I want to discuss here briefly. First off, remember in our little example here, we're going to process NFL game files received to our database as external XML files. Well, before we can receive and parse those guys, we need to tell the database where they're stored and then grant the MyNFL schema access to that directory. Well, that's exactly what's going on here in these first couple of commands. As the system user, go ahead and grant directory creation privileges to the NFL user. Next, as the NFL user, create a directory object called external_XML files and point it to the proper physical disk location. In my case, since I'm on Windows, that location is C SQL XML files. Note, make certain Oracle has full control of that directory, because without that, our little game here is simply not going to work. Finally, we create a table called game files, where we will store the external file names, bfile pointers to the XML content, and the date on which the XML content was parsed and brought into the database as truly relational content. Now all we have to do is insert a record into that game files table, and we're off and running with our XML parsing procedure. Well, in fact, in theory, that's all true. But it's my experience that getting that first bfile pointer to work properly and then actually parsing your first XML file takes a little work. So let's examine some of the potential issues. We'll start by taking a look at the syntax of this insert statement. We'll get some clues here. First off, typos are not your friend in these file name literals. If you type like I do, that can be a big problem. I swear as I get older, my typing has gotten worse, and that's really hard to believe because it was pretty bad originally. Next, the XML type is really nothing more than a glorified bfile type, so we need this bfile constructor. Remember, and this is an important one, Oracle converts all directory object names to uppercase. I swear, dumbest thing they've ever done, but there it is. I mess this one up every time. Despite my having used lowercase to define the directory object above, I now need to quote the directory object name and use all uppercase. Sorry, this one's so dumb, but we just have to memorize it. That's because of people at Oracle messed it up and they absolutely refuse to fix this otherwise known issue. Oh yes, and by the way, remember Oracle must have full access privs to that specified physical directory. Finally, any formatting issues with the actual XML content and the insert will fail for that as well. Again, better check it twice if you freehanded that XML file creation like I did for this little example. What's the good news on that particular point? In the real world, we all know that 99.999% of all XML files are going to be created by a piece of software, so they get properly formatted. Just know the associated scheme and you should be fine. Anyway, after finally remembering that stupid uppercase thing on the directory object name, mine finally completed successfully and the insert was able to be committed. Cool. Now we can write a procedure to parse this XML content. Alrighty, let's take a look at our procedures. Procedures have three main sections and an optional fourth error handling section. The initial section is called the procedure signature. In our example here, we start off with the keywords create or replace, procedure, and then the procedure name. Please note the or replace segment is actually optional, but everybody always includes it as standard practice, and its utility there is pretty self-defining, so just go ahead and normally do that. Next comes a comma-separated list of procedure parameters. Parameters can be input, output, or both. If they're both, you simply include both the in and out keywords. The procedure signature concludes with the keyword as. Interestingly enough, the keyword is also valid in lieu of the as. Either is just fine to the compiler. The next section of our procedure is the declaration section. This section is where you're going to declare local variables, any local data structures as local tables or types, records, that sort of thing. And it can also include, interestingly enough, other locally embedded procedures which are available only within the scope of the current procedure. That's a little more advanced for us, so we'll take a look at that a little further down the line. But for now, please understand that this is where we're going to declare our variables. Also please note that you can default some of those variables at this time, and we've done that here. Alrighty, then our final required procedure section is the procedure body. The procedure body is delineated by the initial keyword begin and culminates with the keyword end followed by the procedure's name. Again, we'll see the importance of this procedure name qualifier when we start dealing with embedded local scope procedures a little later on. Oh, and a special point about the body of our procedure. It must contain at least one executable command or the compiler will throw an error. The same is true about any control structures like if-then-else statements or a for loop. Just building a stub for subsequent code population? Not going to work. Remember, you still need to add one line in each area or the compiler is going to throw that error. My favorite useless line of code, select one from dual. What a beauty. And finally, our last section of any procedure is officially optional, although it's nearly always included in any production piece of code, and that's the exception handler. As we discussed in our error handler lecture, errors can be trapped individually, en masse with the when other option, or passed up the calling chain to a higher level handler. It's all good. Here in this procedure, I left my standard debugging error handler in there, which throws both the error number and its associated message. If this were going into production, I'd swap that out after testing to my standard when other error handler option. Enough about that. Let's move on to the actual code logic. This is the good stuff. This procedure is designed to parse an XML game file and then store the associated information into relational tables so we can subsequently analyze these things. We pass the external XML file name into the procedure and pass back out the newly created game ID and the number of associated gameplays. Here's an image of our example XML game file. I've also put a copy of this guy in the resource materials list for this lecture, so feel free to grab a copy and check it out there as well. Anyway, as you can see, the file is divided up into a master-child configuration with the master game information at the top and then all the child series play records down at the bottom. We'll start our parsing process with the top master level game information. The syntax for parsing an XML file is really pretty straightforward once you see it and use it a little bit. We simply use the extract value function to navigate the XML path hierarchy to our desired tag value. Now please note, we're going to use the extract value to get just the value. If you use just the extract function, it pulls out the associated tags as well, so you might want to play with both of those. Alright, back to our example. In this first command, the user tag is immediately below the game tag, so we search the XML file contents down that path to our desired user ID value. What is so cool about this? Well, that XML pattern transversal is actually being conducted outside the actual database by our B file pointer associated with our external directory object. Yeah, that is pretty darn cool. The XML Oracle combination is actually very sophisticated in this regard. You can pull this stuff in and make it truly relational without having to have those stupid blobs hanging around. Alright, the next few commands just play this same game to get the remainder of the game or master attributes. Please note, none of these extractions involves a null value check, so we are in fact therefore assuming all these tags are required. Okay, our next little chunk of code extracts the home and away team scores from our standard XX-YY input format using the substring and instring functions. Again, pretty straightforward stuff once you've played with these functions a little, and also they behave just like the ones you've probably already used in your other programming languages. More specifically, the substring function takes 3 parameters and returns a string. The first parameter is the original string. The second parameter is the substring starting position, and the third parameter is the substring final character position. By the way, Oracle string functions all reference the first character as being located at position 1, not 0 like many of us programmers would actually prefer. The instring function is equally straightforward. Instring takes 2 strings and returns the starting position of the second string within the first. Just study these couple lines of code and you'll see the magic right away. I'm sure you've also used similar functions in previous languages. They all work pretty much the same when we're dealing with strings. Alright, moving down the procedure body, our next little paragraph of code gets the user the next available game ID. The thing to know here is that the null function takes 2 parameters. If the first parameter evaluates to null, then the function returns the second parameter. In our case here, we test whether the max game ID plus 1 parameter evaluates to null, and if it does, we return a value of 1. Net, what are we talking? What are we doing here? If this is our very first record inserted into the games table, we use an ID value of 1. Otherwise, we go out there and grab the max and increment it, and that's our next game ID. Again, very standard practice. Finally, we do an insert of our new master record using inline views to retrieve the team IDs corresponding to the team names we found in our XML file. That's pretty elegant stuff right there, guys. I would suggest you memorize that syntax because that is a pretty nice piece of code. Alrighty, if we now examine our XML file again, we see are ready to start processing the repeating series in play elements. In particular, it looks like a game can have 0, 1, or many series, and that a series is defined as one squad of players executing 0, 1, or many plays. Guys, that's standard relational thinking. Now Oracle treats repeating elements as though they were arrays, with the first element in each array assigned an index value of 1. As such, standard practice is to use a couple of nested loops and their associated loop control variables to step through the repeating elements. But before we look at our looping code, let's check out a specific example of a repeating XML element. Here's the syntax for retrieving the first series tag value. You put a 2 between those brackets and it gets the associated second series tag, and so on and so forth. Our XML schema doesn't have a value between the starting and ending series tags. Instead, the series tag only has an attribute. More specifically, our series tag contains this team attribute, which is used to identify which squad or group of teammates is on the field for the following series of plays. To read an attribute associated with a tag, we use this @sign syntax. This example would read the team attribute from within the second series tag. Okay, finally, let's look at an example where we have nested repeating tags. This extraction would pull the value associated with the third play of the second series. Very nice. Now let's put this information to use with our for loops and their associated loop control variables. We start with the outer for loop and its associated loop control variable aptly named series LCV. But how do we know what to use for our max LCV value, you ask? Short answer, we don't. We'll do an existence test before we do the actual extraction, and if the existence check fails, we'll simply jump out of the loop with an exit. I know, not terribly elegant to use that exit, but it's also pretty standard practice for when you don't know how many elements are going to be in a collection. All right, check it out. The exist nodes function returns a 1 if the specified tag exists and a 0 if it doesn't. As such, this select will return a count of 1 if the node exists and a 0 if it doesn't. Also, check out how we build the array index syntax through concatenation of the loop control variable and the literal stuff. Again here, guys, probably best just to memorize this stuff because it's used very frequently and we need to know it. You may very well see this in previous languages as well. That's pretty standard practice. And of course, this snippet then checks the existence check variable and exits the loop if the node does not exist. Alternatively, it simply extracts the series team attribute in a local variable. Okay, moving on, the next couple of pieces of code do some simple lookups, so we'll just jump over them to our second nested for loop. This time with an LCV cleverly named play LCV. Oh my goodness, where does Rick come up with these things? Anyway, same basic game here now, but we are concatenating in two LCVs, and in a couple of cases checking for null and in assigning an appropriate value if the attribute does not exist. Please check that syntax as well. We of course finish each inner loop with some lookups and ultimately insert our new child gameplays record. Ta-da!
All right, that was great fun. I hope you enjoyed. I think that was a great first example because it's something we all need to know how to write, and we'll just put that one to memory. So what did we learn in this lecture? Well, first we learned how to open an XML file within a external directory object. Remember a couple things to get started there. First off, Oracle needs privs to that directory. For some reason, Oracle creates that object in all caps, and you need to specify it as a literal. And then, of course, the XML file needs to be properly formatted before that insert will actually take place. Next, we learned how to extract values from within an XML file. Pretty straightforward stuff. Once you know the syntax, you just say extract value, the field from which the XML content is stored, and then the XML tag path you need to follow to get there. We culminated our discussion with the retrieval or the extraction of repeating groups from within an XML file, wherein we used for loops and the loop control variable as our index value within the repeating field. Again, not very difficult syntax once you've seen it and you get your hands around it. Do remember that those literals do need to be made up of the literal components concatenated to the loop control variable, and you're pretty much home. All right, that concludes this particular lecture. In our next one, we are going to take a look again at another procedure, a little more advanced this time, and also the debugger. In the interim, hey guys, you go out there and you have some fun, but you learn something every day because it's what's important.